Alright guys, so we just got done talking about direct variation and joint variation, and we determined that the equation we're going to use for both direct and joint variation is going to be y equals kx, right? So this is what we use for joint and direct variation, okay? Well, now we're talking about inverse variation, right? So it's a little bit different, but the same concept applies, okay? So this is the equation we're going to be using for inverse now. And notice I still have my k here, which is our constant of variation. So we'll just write that in again. K is our constant of variation, okay? So the same concept applies here. We just need to plug in our values, all right, into the variables. Okay, so this is the equation we're going to be using for inverse variation. Now let's read the problem here. It says y varies inversely. So you immediately think inverse variation, meaning we're going to use this equation, okay, as x. And when y equals 3, when x equals 8. So when y is 3, x is 8. Write and graph the inverse variation function. Alright, so the first step we need to do is find out what this inverse variation function is. And then from there, we can go ahead and graph it. So looking at this, in order to find what this inverse variation function is going to be, we're simply just going to plug in our values and solve for k. Right, we're going to solve for our constant variation. So we know that when y equals 3, x is going to be equal to 8. So we plug it in. Alright, and when we solve for k here, we multiply by 8 on both sides. K here will be 24. Okay? And if we want to write this now as the inverse variation function, we'll just write it as y equals, we'll have 24 over x. Okay, and from here I can go ahead and graph it. So all I did was take my k, plug it back in, and now I can start plugging in values for x, and I'll return a y value, right? We can go ahead and start graphing it. All right, so why don't we go ahead and erase this work, and we're going to start graphing it. So we're going to need our inverse variation function, so I'm going to write that up here. I'm going to erase this so we can start graphing it. So what we have, we know that it's going to be y equals 24 over x. Let's go ahead and start making a graph, and then we'll build a table of values. So making our graph here. Okay. And let's go ahead and start plugging these in. So you can pick any values you want for x, it really doesn't matter. Okay, I'm just going to pick some random values here. I'll pick 3, 4, 8, and 12. So we're going to use these values, 3, 4, 8, and 12. So 3, 4, 8, and 12. And let's see what happens when I plug these in. So when I plug a 3 in, okay, to x, what happens? 24 divided by 3, and we get 8. So we have a point here. So we can say 3, 8, right? How about here when I plug a 4 in? Well, 24 divided by 4 is 6. So we're going to have here 4, 6, right? What about here? I plug in an 8, right? And what happens? Well, I'll get 3, so I get 8, 3. Plug in a 12. What do I get? I get 2, right? So I can go ahead and graph this part. So let's go ahead and do that. So starting at 3, we're going to go up 8. So 1, 2, 3, and then we're going to go up 8. 1, 2, 3, 4, 5, 6, 7, 8. Let's make a point. Then going to 4, we're going to go to 6. 1, 2, 3, 4, 5, 6. Going over to 8, we're going to go up 3. So 4, 5, 6, 7, 8. And we're going to go up 3. So right here. And we're going to go over 12 and go up 2. So 9, 10, 11, 12, and we're going to go up 2, right about here. Alright, so we can see what's happening. Okay, we're going to have a basic shape that looks something like this, right? And not the prettiest, but that's what it should look like, right? And now let's go ahead and figure out, well, what happens when I make these x values negative? Alright, so instead of putting in 3, 4, 8, and 12, what if I make them negative? I'll get the other side of the graph. So let's go ahead and do that. So now we're going to plug in a negative 3. Okay, so we're just making the values we originally plugged in negative so we can get the other side of the graph. Okay, so let's go ahead and plug these in. When I plug in a negative 3, okay, well in this case I'm going to get negative 8. When I plug in a negative 4, I'll get negative 6. When I plug in a negative 8, I'll get a negative 3. And when I plug in a negative 12, okay, I'm going to get negative 2. And again, we can go ahead and graph these out. So we're going to go over negative 3, and then we're going to go down 8. So 1, 2, 3, and then down 8. 1, 2, 3, 4, 5, 6, 7, 8. Over negative 4, down 6. So now we are right here. Over negative 8, down 3. So 5, 6, 7, 8. 3. And then over negative 12 and down 2. So 9, 10, 11, 12, and down 2. And we have this side of the graph now. So we just went ahead and found, okay, the inverse function, and we used our equation here. So when we're solving for inverse variation, we're going to use our inverse equation here. Okay, so it's very similar to direct and joint variation. You're just using a different equation here. And if we want to go ahead and graph it, we can use the inverse variation function that we found and put it on a graph. Okay, so that is inverse variation.